people, welcome back. And this session we are going to learn about the process capability long-term calculation. So in the last session, you remember I explained you about how to calculate the short-term versus long-term. Just to give you a brief, suppose you are going to buy a new product or new machine. Initial validation you are doing, so you will not be able to collect a large amount of data for that. So we collect few of the data points, maybe 10, 15, 20, 30, 15. That is a short-term data. When you are running your machine for a longer period of time and you are checking the actual performance, like as maybe 20 days, 30 days, 40, 50, 60 days, 90 days performance you are checking. So that is the long-term data, and that's how we calculate the long-term capability. Basic difference between the long-term and short-term calculation is only the way we calculate the standard deviation. So last time I explained you the standard deviation for the short term, we use the range method because the smaller is the data, range is the better measurement variation. But when you are having a long-term data or the large amount of data, so we can easily calculate the standard deviation of the data by using the deviation method, and that's how we put this for the long term. Now let's understand short-term capability. What does it mean? This refers to the potential performance of a process under a control at a point in time. It is calculated from the data taken over a short period of time, such as there is no external influence on the process. Let's say simple, the data which you are collecting for a small period of time, maybe 10, 15, 20 data points you are collecting, and you are checking what is the potential we have in the process. So example wise here, temperature change, shift change, operator change, etc. does not influence the short term. Short-term capability represents a true process capability that indicates the technology of the process. Either it has a potential to meet the target value or not. While the long-term capability, which we are going to learn now, refers to the actual performance of a process over a period of time. Because now we know testing we have done, and it's time to run the performance, time to see how my process is performing. So this is the actual performance of a period of time, and it is calculated from the data taken over a period of long enough, such as external factor can influence the process. And long-term capability represent both the technological as well as the environmental factor that affect the process. Now let's understand here. Formula still remains same. So as we know, the short-term one capability, if we talk about, that is represented by the CP and CPK. But when you say long-term capability will represent by the PP and PPK. Formula remains same, like as we have the formula for CP. CP is equal to USL minus LSL divided by 6 times of standard deviation. But only difference here is the standard deviation which we are calculating will be using the range method. CPK is the minimum value of CPKU and CPKL. How to calculate CPKU? CPKU is equal to USL minus average value. USL is the upper specification limit minus your average value. What is the average of the process? Because it talks about the half of the process. So half of the process variation means 3 times of standard deviation. Because when we calculated CP, we divided it with the 6 times of standard deviation, but the half of the process variation will be 3 times of standard deviation. This is your CPKU. Similar way, CPKL will be calculated. CPKL is equal to average value, because lower specification will be less than the average. So average will come first, then lower specification limit, then again half of the process variation, which is 3 times of the standard deviation. And whichever is the minimum value out of this CPKU or CPKL will be, that is your final circuit. Exactly the same way is your PPK. So the PP calculated with the same formula. PP is equal to USL minus LSL divided by 6 times of standard deviation. Same formula, but only difference is that The standard deviation which you are using here in short term, we are going to use the range method, which I explained you in the last session. You just go and watch the last video for the short-term capability. And the PP, the standard deviation, we are going to use with the deviation method. They will calculate it. Now PPK will be PPKU. PPK will be minimum value of PPKU and PPKL. Now, same way we'll calculate the PPK as well, like as if I copy paste these two formula, and only thing I will do, replace the CP word with the PP. So PPKU is USL minus mean divided by 3 standard deviation, and the similar way, PPKL will be mean minus LSL divided by 3 standard deviation. Let's take the machine which you have bought, all the instrument you have taken, or maybe mobile phone or anything, or any process which come with the specification. You have done the validation of the machine, and machine passes the validation, which means the short term is successful. Now I want to see the actually how the process is performing over the long run. Is it process is able to consistently perform the same way, which is able to retain the what you have given as an initial input, the way it was performing, it is able to perform in the similar way or not. Or the process is able to sustain what it is meant for or not, that we calculate in the long-term basis. How do we do this? So we use the formula. Let's say you have a machine, which machine comes with a production capacity of lower specification limit and the upper specification limit. Like as it should be producing at least 40 product and not more than 50 product as well. Or maybe these are the dimension of a dice, that dice which you are using, or maybe dimension, you can consider anything, whatever is your process is, that the dimension are 40 and 50. Now I'm generating some data for this. So here is your production data. Now production data you have collected over a long run, maybe it is perfectly between, let's say 41 to, I will say 48 plus some random value, which is the 0 to 1. So these are the dimensions are coming. These dimension I have collected, let's say I will be generating some values, maybe around 40-50 value will be good enough. So let's generate some value. And these are the total 43 and 45 values we have generated. Now this is 45, double click here, these 45 value I have got. I wanted to calculate the capability for this long term. So for calculating the long term, if you look this formula, what I need the lower and upper specification limit already available. What I need, I will be looking for the average value and the standard deviation value. I will first copy paste this value as a value, so that value will not change, from where will go away. Now, if I look for this average, I will be using the formula. Here is the average, here is my data, and I got the average value of my production is 44.29. This is the main thing, standard deviation here. As I was telling, when we are calculating for the short term, we'll be calculating the range method. When we are calculating for the long term, we'll be using the deviation method. So the formula which is available in Excel, stdev.s, that is based on the deviation method. Just select here, and here we go. 2.13 is the standard deviation. Now your work is done. You can use the formula CP. How we calculate CP formula? USL minus LSL divide by 6 times of standard deviation. So my CP value, PP value is 0.78. Less than 1 does not consider as incapable process. Why? When I will convert this into the percentage data or DPMO, then you will understand. So now my PPK U is USL minus mean divided by 3 times of standard deviation. PPKU is 0.90. PPKL is equal to mean value minus LSL divided by 3 times of standard deviation, which is 0.66. So whichever the side, the value of the capability PPKU or PPKL is low, lower the capability means there is a higher chance of defect. Whichever the side the value of capability will be low, which means that side of a specification, we are generating the higher chance of defect. So like as if we see how this graphically it will look like. So suppose here I am drawing the graph. Let's say this is your lower specification limit is here, and upper specification limits are here. 0.78 is your capability less than 1, which means there is a higher chance the data is going outside the specification. And suppose the graph is here. But because my lower side capability is low, so chance of defect on the lower side will be high. So this graph actually process is shifted towards this side. Now you look at this graph, I am generating the defect on the upper as well as lower side. Upper side is very, very less defect, but lower side there is a lot of defect which is going outside the specification. Why? Because my lower side capability is low. That's the way we read this capability. Now, what does this capability mean and why do we calculate this? You will understand this when I will convert these value into sigma level. So like as we have calculated, so what is my these PPKU and PPKL, I will be converting into the Z value. So Z USL and Z LSL. This is the simple formula. If Z LSL or USL is your 3 times of Z USL is 3 times of PPKU and Z LSL is 3 times of PPKL. This is the way we calculate. So PPKU, I have calculated 0.90 multiplied by 3 and PPKL, I calculated this and multiply by 3, you got the Z value. So 2.70 is your sigma level on the upper side of specification and 1.99 is the sigma level on the lower side of specification. Now, if you want to see if this sigma level means, so this sigma level means the yield or the probability that what percent of data, what are the chance that data will fall within the specification. So this data 2.71 and 1.99 can be converted into the percentage. So this is percentage is on the upper side of a specification and this percentage here is the lower side of a specification. Then what are the chances that data will not miss 40 and 50 specification? So if I see USL, I will be using the formula norm as dist, which takes your Z value, Z is sigma level, and convert into the percentage data, which means on the upper side, there is a 99.66% chance that your data will not miss the upper specification limit of 50. Which means, what is the chance of defect on the upper side of specification? Will be is equal to 1, which is 100% minus 99.6 is 0.34% chance that your process will generate the defect. The same way, if I calculate on the lower side probability, same formula I will be using norm as this, getting 1.99 and 1.99 is equal to 97.64%. Which means there is a 94.65% chance that I will not miss or my process will not miss the lower specification limit. So what are the chance of defect? So defect LSL or the lower side of specification is equal to 1 minus is equal to 1 minus this value, which is 2.35. So this is my defects, which I got it here. Now, because I am getting the defect on the lower side as well as upper side, so what are my total defect? Total defect will be in the process the sum of the upper side as well as on the lower side. So 2.69% defect will be generated in my process. So what is my final probability or final yield without defect is 100% minus the total defect, which is around 97.31. And this 97.31 can be converted into the Z bench. G bench is your final sigma of the process by using the formula norm sine V, norm S inverse. So 97.31 is equal to 1.92 sigma level. So what we got? We got the process capability here. We calculated 0.78 pp, ppku, ppkl, and we calculated the sigma. Now